This is our fifth video on polynomial inequalities. And in this video, we have x squared minus 3x bigger than 0. And it is a quadratic inequality. So in order to find the critical values, as I have explained in the first video, I can factorize that expression. So I can take out the greatest common factor of x. So it'll be x times x minus 3 is bigger than 0. Then to find the critical values, I'll place x equals to 0 and x minus 3 equal to 0. Therefore, x would be equal to 3. So my two critical values would be x equal to 0 and x equal to 3. And as before, we explained that those values represent the roots of the parabola, where the one root is equal to 0 and the other root is equal to positive 3 on the x-axis. So these values are also the x-intercepts. But we are not concerned with the parabola. What we rather want to do is solve this inequality. So I plot these values on a number line. So I have x equals to 0 and x equal to 3. And what I want to do now is determine where this graph is positive and negative on this number line using these points as critical values. So what I recommended is that we substitute a value of x after 3. So let's say we use 4. So if I'm going to use 4, I have 4 squared minus 3 times 4, which is equals to positive 4. And that is a positive value. So meaning after 3, the expression would be positive. So I have positive, then it will turn to negative, and then after 0, positive again. So the question is, where is x squared minus 3x bigger than 0? And it is bigger than 0 in the sectors on the number line where we have the positive signs. So everything to the right of 3 and everything to the left of 0. And if you know how to plot the parabola, you can see that after 3, the parabola would be positive or above the x-axis. And to the left of 0, the parabola would also be positive or above the x-axis. And how I write that is x must be bigger than 3 and x must be smaller than 0. So if I substitute any value smaller than 0 or bigger than 3, it will give me an answer that is positive or bigger than 0.